Okay, now we need to optimize a optimization of the new design that we have. So if we look at the optimization of the design, we need to optimize the thickness of the part on this shell thickness. So first thing we want to do is we want to go in and we want to evaluate and then create a design study for the unit. So we start by creating a design study of the unit, and then off this design study we want to add a parameter. All the parameters are going to pop up. We're looking for thickness, and that's the 77 right here. So if you touch it, once you have it up here in the number, you just type in the thickness. So I'll just say thick, and there's the thickness of the design. Now the minimum value, we know off this study that this thing's already hitting pretty good stresses, so we can go with 80,000 as our minimum. And then up at our maximum, we can take our maximum up to, let's say, 200,000. The step variable on them, say like 20 thousandths or 30 thousandths, so I'm going to go with 30. And then the mass we don't want. We want to add a sensor. That sensor is going to be our simulation data, and then it's going to be the stress of the unit at its von Mises. We want the variables to be PSI, so that's the unit that we want it to be, and then model max. So hit check there. Next thing we want to do is we want to actually go back and we want to change our design study material. Let's make sure that we're in this different material. So plate carbon steel, I'm going to edit it and check and verify that we're in the 100,000 range. This one, plain carbon, that yield is about 31. So we're going to shift over to alloy steel on the design, and we'll hit apply and then close. So off of this, if we shift over to that one, let's go ahead and run our study again over here. So we'll just run the pressure study and see what happens on our design. So we might have to go down in thickness a little bit. So there, we're dealing with it, and that looks pretty good for the design. So we go back over to our design study sitting here. Our design study is going to be run, and it's going to be run off the stress variable on it, and we want our stress to be at 20 grand. But first we want it to be is less than, so watch out there. And we want it to be less than 20 grand, 20,000. Put it in there. And then this is the study that it runs off of. And then our goal is going to be the mass, and we want the mass minimized on the design. So we are ready to go ahead and run the study at this time. Off of this, a lot of times I'll hit save, make sure I'm saved, and then I'll run the study. So we can talk a little bit while we're running the study. So first thing I see is this number that pops up, and it tells me that I have 7 studies that are going to happen. It's a good one to watch, because if you notice that you got like 600 studies that are going to be optimization, that could be a problem. That could be a headache all the way through when it's doing its optimization up through the design. Next thing we know, we notice the stress variable right here, and when it jumps down. So you can see we're getting close. We should hit it at 14 or a 17 on the design. So right there, we're right at the level. So 14 to 17 is where we should hit. We should hit at the 17 with no problems. Okay, so right there we see that we've hit on the design, but we've taken a step from 20 down to 16. So we have to stay in between those two units on the design. If you wish to run another optimization, you can run between 14 and 17 and figure out exactly where it is on the design. But the way I look at this, this is roughly the size of the materials that we're going to purchase. So right now it looks like our optimization comes in at 17, and our stress variable right there. So The best way to look at this is, if you look at it right now, it's gray and it's just a crazy thickness. But if you touch on your optimization right here, and then you come over and you look at your results of your stress, when you double click on that stress, what it'll do is it'll take you to that optimization for your model, and that'll put it at your model size right there. You can save this design scenario in an Excel formatted sheet, or you can also produce a report for the design. These are excellent things to be able to give to the engineers. So right when you're doing the design, you just pass this information over to them, and they're able to work off of your data that you produce. On producing the report, you just touch for the report, and it pops up for the report. Put the designer in the company, and then hit apply, and make sure you're saved at a certain location on the design. I hope this helps you out. If you wish to see the colors again, you can go here and double click on stress, and then it'll tell you where the stress is and where it's optimized. So right now we're optimized with our model, and we optimize at a 89 is our yield. So right here we've optimized to a safety factor of about 5. And why different? Because you want to optimize something like this that's very dangerous. Instead of being a safety factor of 3, it's more like 5 on the design, because of the crazy mistakes that could happen. Alright, dropping out of a truck or anything like that. If somebody's just sitting out there and a kid knocks it off of a deck and it hits the backyard, you don't want it to explode or anything like that.